Hello guys, this is Dupz the Genius once more. Yes guys, this is a continuation of arithmetic sequences. Now we are dealing now solely with arithmetic sequence. What are these sequences? Now let us recap what we did. Arithmetic sequences are also referred to as linear sequences. Now, these are sequences where you have a constant difference. Now, what is the importance of this constant difference? If you want to get a successive term, you need to add this constant difference. Now, why do we say it's constant? It means it doesn't change. That is, the difference between two consecutive terms remains being the same. For an example, term number 2 minus term number 1 must be equal to term number 3 minus term number 2, and must be equal to term number 5 minus term number 4. If the constant difference is the same, then that is when we will say that is an arithmetic sequence. But if you get different differences, it tells you that that is not an arithmetic sequence. It is not linear. We call it random sequence. Wow. Yes, mathematics is so fascinating, guys. Yes, now these are sequences, are a list of numbers following a certain pattern. Yes. Now, what is the purpose of this lesson, guys? Guys, today we are going for an exploration. We are going to explore the arithmetic sequence. That's why my topic is exploring arithmetic sequences. How are we going to do that? 1, we have to check whether this is this really an arithmetic sequence. How are we going to see whether it's an arithmetic sequence or a random sequence or any other sequences? Our constant difference. If you check the difference between term number 2 and term number 1, term number 3 and term number 2, and you get a constant value, that should be an arithmetic sequence. Now, let me show you. Suppose we have, let's take a sequence like this, guys. Suppose we have 25, 27, and then 25, 27, and then 20, 29. And then the question is this really an arithmetic sequence? Let's check. How do we do that? Now, the solution is we are going to check the constant difference. Let us check the constant difference. Now, our D, which is the constant difference, must be term number 2 minus term number 1, and it must be equal to term number 3 minus term number 2. In this case, we have term number 2. Term number 2 is 27. Let's write that in a different color. Then subtract 25. And this gives us 2. It gives us 2. Now let's check. This must balance. Term number 3 minus term number 2. Term number 3 is 29. Then we write 29 and then subtract 27. And let's check the answer. The answer is 2. Now, what do we see? We see that the differences are the same, meaning, therefore, it is an arithmetic sequence. That's it, guys. This is how we do it. So, in order to really check whether a sequence is arithmetic, you have to get a constant difference being similar. Yeah, it's constant. It doesn't change. It doesn't vary. So, if it doesn't vary, therefore that will be an arithmetic sequence. Now, is that the only way of checking whether this is an arithmetic sequence? Yes, that's it. Now, another way of exploring this is, can we derive the formula for the given data? Whew. Let's check, guys. This is the formula. Number 2, the formula. Derivation of the formula. Fine. How do we do that? First and foremost, you have our A. Our A is 25. Now, secondly, we have our D. Our D is equal to 2. That is what we got. Now, meaning, in order for us to get, this is number 1. Number 1, we have to get number 1, we have term number 1. And secondly, we have to get our D. And then, what are we to do? That is the third thing. What are we supposed to do? Good. The general formula. Now, what we know is Tn. The general formula is Tn is equal to A plus, I just want to show you something. I would like you to do this. N minus 1. Please put the D in front of the brackets. I have a reason for that. So, what do? You substitute this 2. Your A is 25, then put in 25, then a plus, then your D is 2, then into N minus 1. And then what next? That will be your A is 25, and then D is 2, then it remains being that because we don't have the value of N. So what do? Brackets. We remove the brackets, that will be 2n minus 2. We have 25 plus 2n minus 2. 25 and 2 are like terms, therefore that will give us 23 plus 2n. Now, this is Tn. And likewise, guys, I want to show you something. Likewise, we are going to check on this. Look, when you do, we said this is a linear. Now, a linear function, this is a linear function. Now, linear function is defined by y is equal to mx plus c. Now, let us look in this case. How are they similar? On this side, we have Tn equals, we have the constant is 23. And then we have 2n. Now look at that, guys. We have 2n. Now meaning, in this case, look at that. The constant difference is equal to your m. The constant difference is equal to m. And then, how do we get the c? I'm going to show you. C is always the first term. Look at this. In order to get this, if you take C is equal to term number 1 minus the constant difference. And term number 1 is 20. Term number 1, yes, term number 1. Term number 1 is the constant difference. That no, it's not the constant difference, no. It's term number 1 minus the constant difference. Term number 1 is 25. Now subtract the constant difference, which is equal to, then it will give you 23. Guys, now this is how you do it. And then look at that. This is linear. Now, but the question was, how do we derive the formula? By getting this. This is the formula. Now, let's substitute. Term number 1, we know that term number 1 is 25. If we substitute n by 1, that will be 2 plus 23. That gives us 25. Substitute by 2 is 2 by 2. That is 4 plus that is 27. And we know that our sequence is 25, 27, 25, 27, 20, 29. And that's it. So we need to be very, very, very accurate, guys. And this is how we do it. This is how we do it. Make sure that everything that you do is up to scratch, guys. So let's move on. Let's move on. Yes, I am just about to show you something. Can we derive a formula? Yes, we did. And then the third one. How can we determine how many terms are there in a sequence? Oh my God. Let me give you another sequence, guys. Let me give you another sequence. I'm going to give you another sequence, and then let's explore. We are on a journey, exploration journey. Let's do it. Yeah, the first term here is Yeah, the first term, let it be 25. Let the first term be 25. Yes, it's 20, 25. And then the second is 31, 31. Then the third is 30, 37. And then 1, 2, 3. The last term is said to be 175. Oh my God. Let us recall our question. How can we determine how many terms are there in a sequence? Guys, remember, these are terms of the sequence. Now, what is common with them? They can be derived by making use of the formula. Now, let us recall. How do we get the formula? How do we get the formula? By using the general term, guys. Let us use the general term. Tn is equal to A plus D into n minus 1. Now, in this case, let's check. Our A, let me use a green one. Our A is equal to 25. And what about our D? Our D, yes, our D is equal to 31 minus 25. 31 minus 25, and that gives us 6. Therefore, our D will be equal to 6. Now, let's check. We are now to substitute. We have our D, our A, and then remember, here we are supposed to determine which term is this. Determine which term, meaning we are going to determine n. So what do? We take the general formula, then let's substitute. Then our Tn, this is what we need to find, which term of the sequence is this. Then that is Tn, because in order to get all these terms, we have to use this. So this can be represented by that. So Tn, it will be 175 equals A is 25, then plus the constant difference is 6, and then you have n minus 1. Wow, it's gonna be so fine. It's interesting. So subtract this. That will give you 150. And then we are left with 6 multiplied by n is 6n minus 6. Now add 6 both sides. That gives you 156. Then you're left with 6n. And then what are we supposed to do next? Yes, ready for danger. Yes, we divide both sides by 6. And what do we get? Here it's n, which is equal to 6. How many 6's are there into 1? No. Into 15, we have 2. And that makes 12. Then we are left with 3. It will make 36. How many 6's are there in 36? That will be 6. Therefore, our final answer is 175 is equal to term number 26. And it's true, guys. So this is how we do it. Remember, we are still exploring the arithmetic sequences, linear sequences. Isn't that great, guys? It's great. Yes. You add and subtract. When you deal with arithmetic or sequences or linear sequences, you add and subtract. That's it. Now, let's get to the next item, which is a mean. What is a mean? Are these numbers mean? No. A mean is sometimes referred to as an average. An average. Now, let us find how to start. That is the mean. What is the formula for the mean? The formula for the mean is equal to the sum of all samples over the number of the samples. Now, when we want to represent that, we will say the mean, yes. Mean is equal to the sum of this over n. That is the mean. And sometimes this can be represented by that. This is how they represent it. The mean is equal to the sum. This is sigma notation. The sum of n terms, then divide by n. And this is how you represent the mean. It's x and then a bar on top of x. It's called the bar. This line is called the bar. So this is how we get it. Now, let's say for an example, we have to find the mean. The mean, it says the mean between 37 and 105. What do? You say the mean is equal to the sum. This is between two terms. You add them up. That will be 37 plus 105. And then divide by their number 1, 2. Divide by 2. And that will give you, let's check. 5 is 12. Then 4, 1, 4, 2. That will be 142 divided by 2. And that gives us 71. Now, therefore, our mean will be equal to 71. And that is how you are going to determine the mean between two terms. Guys, you are not only going to determine the mean between two terms. Let me show you another one. You are also going to find the mean between more than two terms. So, in order to do that, we need to go back to the drawing board. It says the mean is the sum of all the samples. Say, for an example, I was given this. Yeah, let me put it here. Say I was given these terms, that is 3, 7 plus 5, and then 5, 1, and then 100. They said find the mean between this. You are going to add them up and then divide them by 3. Let's check. That will be 151, 158, 188. That is 188. Then this is 9, 18, 17. So 3, it's going to leave. This into that. That goes 6. It goes 6 times. Then it leaves nothing. Then into this is 2 times, and then it leaves 2 out of 3. Now this will be the mean. That's it. Now this will be equal to the mean. That is the mean and nothing else. This is great, guys. So in order to find the mean of between 2 terms or 3 terms or 5 terms, then you need to add up all the numbers and then divide by their cardinal number. Cardinal number is their number, the number of those terms. So this is how you do it. Now we were supposed to find the mean between 2 terms. That is what we did. And we also found the mean between 3 terms. And we also did that because we found 62 and 2/3. So that is all that we needed to do. So guys, I will just want to close our lesson by referring you to our PDF book. Go there and do the exercise that I will send in the group. I'm gonna send the exercise, and please guys, before I forget, let us make sure that we share this knowledge with other learners, other schools within South Africa, because I am giving this to you guys for free, because I know I want to help you. So give these people my contacts and tell them how you joined me. Tell your parents about me. Show them the video. And let them also watch what you get in the virtual classes that we are in. Me and you guys. The future of learning is in the cloud, guys. So that is it, guys. Thank you. Now let's meet again tomorrow. Thank you. Hasta la vista. This is Dupz the Genius, all the way from Lady Brand. Free State, guys. Don't forget, we are #1, and we are going to maintain that. Thank you, guys.